So today we're going to learn about how to verify if binary search tree is valid or not. Well, in this case, we're going to use uh, basically traversing through left and right branch, right? So first thing first, on the binary, or as we learned before, binary search is something a tree branching, right? Left and right. So the left supposed to be always less than the root, right? And the right supposed to be greater than the root. So right here, we're going to use simple stack instead of a recursive. We're going to implement that stack. Recursive later. Traversing using a loop is a lot easier to understand in this case. I think. So let's check if tree is not empty. Tree is empty. If it's empty, then we're going to return true, because if it's empty, then yeah, we don't even have to check if the left and the right is correct branch or not, right? So it's just empty, and so we will return true, indicating that this is true. The branch is valid binary. So the next one is basically creating a new node, right? So that will be tree right here, tree.root, sorry. And then we're going to have a new variable called stack, and that will be like a recursive functions. Instead of using heap, we're going to use the stack. So stack.push, I'm going to push tree.root. Well, in this case, current node. Right, and we will use while loop, and stack.length is the one that we are using for this conditions. So if it's greater than 0, then we can traverse through the branch. So first thing first, we will pop current node will be equivalent to stack.pop, and we will check if current node left is valid. If it's not null, if it's not empty, then we will compare the node left value. If it's greater than the current node, which is basically the root, right? Dot value. If it's greater, then we will return false. Why do we return false? Well, the left is supposed to be less than the root, right? So that's why we return false. So any branch on the left side is supposed to be less than the root itself. Okay, and if this condition is not true and we escape that the left is always less than the current value or the root, then we will have to traverse. Less than, where if the left is less than, then we will have to traverse. Traverse using stack.push, and that will be current node.left. Okay, and now we will have to check if current node.right. If it's not empty, we will check if current node.right.value is supposed to be greater than the root itself. But if it's less than current node.value, then we will return false, because the root is supposed to be greater than the right is supposed to be greater than the root itself, the root value. If that condition is not true and we escape that conditions, well, we will have to traverse using dot right. And if everything else is working correctly, then we will have to say that this binary tree is a valid binary tree, so we will return true. So that's for traversing using while loop. So let's see if it's working correctly or not. Control and enter. So that worked correctly, and now we're going to implement using stack method. I mean recursive method. So we will leave this conditions right here as it is, and instead of using this method, we will Control K and C, comment it out, and we will use something called return check BTS. Is it BTS? No, BST. And then we will send basically the tree.root. So we will send that, and we will pass that. And now we're going to implement that functions above here. Functions. So function and check BST, right? And then no. Okay. And so in this case, similar to this condition that we just saw right here, we will return true at the end, indicating that everything worked fine. On the top right here, we will just copy this right here, this conditions. That, yeah. So let's copy that one and paste it right here. Control K U, and see how what we can do with this. So instead of, well, we can change this into current node, right? And then everything else is going to be the same as we did before. And this one, the push instead of the push, stack the push instead of that, check BST, right? And yeah, so that's what they look like in a recursive. And also for the right stack, this right here, copy that, paste that right here, and then uncomment, and yep, everything is correct, working correctly. And we just have to change this into return check BST, and that will give us the right answer. So let's see if it's working correctly or not. Control and enter, and it worked. So that's what they look like in recursive functions right here, and iterative functions, iterative way of doing stack, right? So two versions. And thank you. This is for verifying if the binary tree is a valid binary search tree.